My name is Aviles, and I'll be solving problem number 3. So, what we're going to be doing is determining if the given series is convergent or divergent. And so, the given series is 1 plus cosine n over n squared, starting at n equals 1. And so, I'm just going to rewrite the series down here, and we're just going to consider a few of the convergence and divergence tests we can apply and see if they fit. So just by looking at our series, it's not a p-series because of our cosine n, which oscillates. And the series isn't geometric, and it's not telescoping either. And as for the integral test, it wouldn't be the best choice for our series, and our series isn't alternating either. But one thing we can apply because of our cosine n is absolute convergence. So if we look at cosine n for a moment, what we know about cosine n is that for any n we're given, cosine will oscillate between 1 and -1. But with the absolute convergence, if we apply absolute value to our cosine n, then it's going to oscillate between 0 and 1. And so knowing that, we can take the absolute value of our given series, and instead we're going to have n equals 1, we're going to have 1 plus the absolute value of cosine n over n squared. And the n squared and 1 doesn't have to be in the absolute value because they're always going to be positive. It's just our cosine n that's going to oscillate. And also now, knowing this about our cosine n and its oscillation, we can now apply the divergence test. And if we apply it, it's going to go to 0. So what that just means is that it's not diverging, at least by the divergence test. So we can continue from that point. And so now, knowing this, if we look at it, it looks like a p-series, which is a good starting point because we can actually do a direct comparison test to another series that resembles our given series, which is going to end up being from n equals 1, it's going to be 2 over n squared. And you can see how it resembles our given series, kind of, which is what we want. And so for this series, 2 over n squared, it's a p-series. And with the p-series, you know that our p is equal to 2, and if the value of p is greater than 1, then it converges. So, wait, I spelled that wrong, my bad. Converges by the p-series. Sorry about my handwriting. So we know this, but if we compare it to the absolute value of our given series, we can tell that our p-series is actually going to always be greater than the absolute value of our given series. So we can do a direct comparison with this. So 1 plus absolute value of cosine n over n squared is always going to be less than or equal to the p-series of 2 over n squared. And this is because the cosine will oscillate between 0 and 1. So at a maximum, the absolute value of our given series is going to be 2 over n squared, and at a minimum, it's just going to be 1 over n squared. So for any n we're given, the absolute value of our given series is always going to be less than less than the p-series. And because the p-series converges, that must mean the absolute value of our given series also converges by direct comparison. So knowing this, let's write this. So the absolute value of our given series converges by comparison test. And the series we're comparing it to converges by p-series. And, sorry about that. And from this, we can actually determine that our given series must also converge, So if its absolute value converges, so will the given series. And because it converges by the comparison test, then that must mean that our given series, which is 1 plus cosine n over n squared, absolutely converges by comparison test to the series 2 over n squared, which converges by the p series test, where p is equal to 2, which is greater than 1, which means convergence. So knowing all this, our given series 1 plus cosine n over n squared absolutely converges by a direct comparison and by p series.